Hello, this is the first video in Picture Speak series. I'm Yulia and I use pictures, models, and diagrams as communication tools all the time. Pictures can help attract attention, convey meaning in a compressed time frame, illustrate a point that is hard to explain, or just help grab the attention of the audience. The skill of creating simple, clear, and timely pictures is invaluable, in particular to business architects and analysts, but also to any professional that needs to communicate information to others and capture complex and multi-layered details. Today, let's create a simple conceptual data model together. What are the main advantages of a conceptual data model? It names key business entities, captures relationships between entities, enforces consistent terminology, identifies concepts that exist independent of technology implementations. It helps to support business knowledge, and it can serve as a communication tool for business architects, data architects, and business analysts to communicate with a wide range of stakeholders. Let's get to work. What I will do now is I will share with you what pictures I want to create today. And I have to confess, I love skiing of any kind, and I'm going to create a conceptual data model about ski resorts. So what I will do first, I will search for some data to use as a guideline, and I love to use Kaggle. Kaggle allows you to download a lot of free data sets that you can use for any kind of exercises. For example, you can use it to create simple analytics, to do data analysis. And I have found this data set from On the Snow website that captures information about 331 US ski areas with various information. I have downloaded this data set and I'll show you what it looks like, and we will work with this data set. So as you can see here, it's a comma-separated file that I uploaded into Excel, and I can see here my main attributes of various ski resorts. So every row contains information about one ski resort, and then I have attributes in columns. Now I'm going to use it as a guideline, but here is a trick. When we create conceptual data model or do any kind of modeling, it's important that we understand a little bit more about the data. We need to really feel it and understand what it is. Just looking at the table isn't really enough. So I'm going to show you this ski trail map from one of the resorts at Mount Lincoln, Sugar Bowl, so that we all understand better what type of information we are going to be capturing. So what you can see here is a ski resort which contains 4 mountains, as you can see here. And each mountain is a different summit. Each of these summits will have some lifts going up to take the skiers up, and then multiple trails going down. So whenever you see different lines going down, these are the trails. And for those who are skiers, of course, you already know this. The trails can have different difficulty, which usually is depicted using colors and different shapes. And then I have some terrain parks for like this, for example, for snowboarders and for those that like to do the tricks. And then I have some slow skiing areas that are depicted in yellow. And if you are in doubt, here is a legend that will show you everything that you need to know about this ski area. So this information is helpful to me to have a better understanding of the data that I'm looking at. So let's go back to this data. And I'm not going to use all of the attributes, but I'll look at the names of the resorts, their locations, and then some key information about the summits, for example, the drop, the base, then some information about lifts of different types. You see here I may have quad, triple, double, and other lifts. I have number of runs on each resort, the number of terrain parks, what's the length of the longest run. And again, if you are in doubt at what are the measurement units or what each of these values mean, you can go back to the Kaggle website and read the details. Then I can have the information about years the resort was open, average snowfall, the prices of the tickets, the URL, and so on. So what I'm going to do, I will start building my chart, my diagram, and I'll keep looking back at the data and at the picture so that my diagram makes sense. So I'm going to use a Lucid chart, and I have a free account here which only allows me to have 3 diagrams drawn, but once I draw them I can download them. And I'm going to use this as my template. I picked the free database ER diagram template with crow's feet, which comes with Lucid chart. And very simply, I'm going to define the main entities, the main business entities, and then relationships between them. So I'm going to start with the main relationship between this ski resort and its summits, because I just saw in my picture that I might have a resort that has multiple mountains on it. So what I'm going to do is, first of all, I will create my main entity, which will be called ski resort. And I'm gonna make this bigger so that you can see better. And then I'm gonna grab another entity here and drop it here, and I will call it summit. And because I know that some resorts have multiple mountains, I will say, you know what, a ski resort may have 1 or more summits in it. And I will draw this basic relationship with a default cardinality that Lucid chart helps me set up here, which says that one ski resort may have 1 or multiple summits here. So now, what is the main information about my ski resort that I want to have? It's the name of the resort, which I saw in my diagram. It's the location of the resort. And let me put here the URL, how to reach the website. That's information about the resort. Then what do I know about the summit? Well, each summit will also have a name. And then, as I saw here in my data table, a summit has a drop and a base. These are the 2 measurements that show the height of the result, absolute, and the drop, which is relative. So I'm going to say here that I know what's the drop and what's the base. And usually the difference between the 2 will be the skiing height. Now I have ski resort and summit. Now in my data set, I have information about the lifts. Now, if I look back at my picture, I realize that a lift only can go up one of the mountains. So lift would have a relationship with a mountain, not with a resort. So what I will say is that each of my summits may have 1 or more lifts going up. So I'm going to drop another entity here. An entity really is any object or person or concept that I need to collect information about. So I need to have some information about the summits, and I need to have some information about the lifts. So for example, every lift on the mountain will also have a name, because that's how skiers can find their way around. So a lift will have a name. A lift may have capacity, which determines how many skiers can be on at the same time, and a lift will have a type. For example, I may be a quad or a triple, or I may be a gondola. Now, what's the relationship between summit and lift? A summit can have 1 or more lifts, and I'm gonna draw a base relationship here. Now, as you see, by default, it shows just the many relationship, but I probably want to correct it because a lift, at least 1 lift is required. Otherwise, I cannot go up the mountain. So I'm going to correct my end point to cardinality, which says 1 too many, which is this one. I'm going to select it and say that at least 1 lift is required, but usually there's more than 1. Same now goes to this relationship between ski resort and summit. I need to have at least 1 summit, otherwise I have no mountain to ski off. So again, I'm going to do this. Now, a summit only belongs to 1 ski resort. It's not possible that 2 different ski resorts are managed in the same mountain. Same with a lift. Lift can only belong to 1 summit. I cannot have lift that goes here and here. All right, so I have a few entities here in my diagram. What else do I need to know? I have terrain parks and I have runs that go down each of the mountains. I also have information like skiable terrain, snowmaking, days open last year, etc. Let me just look at this information. I'm going to hide some of the columns here, and let's think about longest run. What is longest run? What is this attribute of? It's probably the attribute of a summit, because for each of my summits, or perhaps for a resort altogether, I want to know what is the longest run. That is what skiers are often interested in. Once they go up, how long they can enjoy skiing down. Here is where we can make some assumptions or do additional research or go back to the On the Snow website to see how they defined the longest run. Let's assume that I've done it and I figured out that longest run is defined for the whole resort. That's usually what is the longest run that is available. So that means that I'm going to add this attribute here to the ski resorts. And let me just see, I need to add more attributes here. And I'm just gonna add one more. And now I'm gonna say longest run is another attribute of a ski resort. All right, what am I going to do with skiable terrain? That's also usually an information about the resort, and it's usually expressed in square kilometers or square feet. So I can add it here. So I'll select my ski resort. I'll add another field and I'll say I will also define here skiable terrain. Wonderful. So my diagram has more information now. I do have a few more attributes they want to find information and place for. So here is statistics about days open, years open, average snowfall, adult prices, whether there is night skiing, and so on. So what I realize here, that this information is a mix-up about the overall information. For example, the average snowfall and some annual statistics. So realistically, some of this information will be recalculated every year because the new season brings with it new information. So my average snowfall, I can say that this is an attribute of my ski resort. However, I would assume that the website On the Snow refreshes this information every year. So probably there is some history behind it that tells me what is the average snowfall of the last year, of this year. Same goes with days open. Days open may fluctuate from year to year depending on the weather and other circumstances. So I'm trying to make sense of this, and I'm going to say that I need to store some annual statistics about the resort. That will change every year, and that will be the information that's recalculated based on that year's season. So I'm going to add another entity that will say resort stats, resort statistics. And that information will be related to my ski resort, and it will contain information that will change from year to year. What that means is that year or season, whatever you want to call it, will need to be one of the attributes of this entity, because every record needs to contain information about that particular season. So I'll say season year, and then I'm going to add the statistics for that year here. For example, days open will be information about that year. Maybe I want to add snowfall. What was the snowfall that year? And I could also add here, for example, ticket prices for the season, etc., if I really want to. Now, this entity will have relationship with ski resort because this information is about the resort. So what is the relationship here? Let's just draw the default line, and let's see if it fits. So the default line says that resort statistics, each record will belong to one ski resort. That's correct, because if I have multiple resorts, I will have multiple lines or multiple records in resort statistics entity. And now a resort will have more years of statistics than just one. If it opened many years ago, if it's a new resort, it may have none. If it's my first year as a resort, maybe there are no records here. So what I'm going to do is here, I will change this cardinality at the end point to say it's 0 to many. So if this is the first year the resort has opened, I may not have any statistics yet, and then I will accumulate statistics every year until I have many. So here I have a conceptual data model with 4 entities: ski resort, summit, lift, and resort statistics. Let's see if I'm missing anything important here. Here I have some information about prices, about more details about the prices, whether night skiing is available. So let's see how I should fit it in, and also the number of runs. So the number of runs is another characteristic of a resort, because it tells potential customers how big is the resort, how much variety is there. So I will add number of runs under the resort here. And then let me think about the prices. What am I going to do about the prices? So prices change every year potentially. So definitely it's not something we can just store with a ski resort, because it's not a stable information, it changes. But also there are different types of prices, as we saw there, and we can always go back to the website of a particular resort and check it. There may be prices for day skiing, for night skiing, for adults, for juniors, for children, etc. So what I'm going to do is I'm going to create a separate entity. It makes sense to me to have a separate one, where I'm going to say that I have a description of different types of tickets that are offered at the resort. And I'm going to call this entity ticket, or maybe lift ticket. Let's just be more specific. In reality, you may have different types of services at the resort sold, including snow schools and private lessons, but let's just focus on lift tickets. And then there may be multiple lift ticket variations at this resort. First of all, I'm going to say every year the price may change. So I'm going to say season year to be consistent. Then I'm going to say ticket type. For example, it could be season, one time, weekly. And maybe I'm going to say age group, because the same ticket type may be different depending on the age of the skier. And now I need the price itself. So I'm going to add another field, and then I'm going to say price. So this way, this entity lift ticket will help me store information about tickets per year, per type, per age group. And now I'm going to connect this information to ski resort, because usually when I buy tickets, they're not for particular summit, they're for the whole resort. Of course, if there were tickets per summit, then you would connect it here. But in my case, most of the time, the tickets are sold for the resort and by the resort. So here I'll say that one ski resort will have multiple types of tickets. There must be at least one, otherwise you're not going to make any money. But I'm going just to say one too many. And then my lift tickets is usually for a specific resort. Again, unless you have a certain package where 3 resorts, for example, agreed to sell combined tickets, but that's not my example. So what I have here now is a nice small conceptual data model that establishes some of the terminology and relationships between main entities about which I will need to store data. The result itself, its summits, lifts, some resort statistics, and information about the tickets. This is how you can go about creating a conceptual model. You can develop it more, of course, you can add more information. The key points here is remember that you need to understand the data itself. It helps to see some of the data collected if it is already being collected by the business. And you need to keep things simple, use proper language so that it's clear to understand, and pay attention to the relationship between these entities. And a simple tool, communication tool like this can help you discuss the data with your customers, with your stakeholders. It can start as a base to create logical data models later, which is what a data architect may do. And it can help business analysts in their analysis activities. That's it for today. I hope you enjoyed it. Happy modeling!